Hi guys, welcome back to another video. This one's going to be a short tutorial on simultaneous equations. So we're going to go through 3 examples, varying levels of difficulty. If you want to give it a go before I go through a worked solution and see if you can get to the answer same as me. And yeah, let's just get straight into it. So we've got a simultaneous equation, a pair of simultaneous equations here. So we've got 3x minus 2y equals 14, and we've got x plus 2y equals 10. Now, when I usually am faced with simultaneous equations, what I like to do is just label them. It just makes it a lot easier as we're going through if we need to do some sort of manipulation with the equations, do elimination or substitution. So what I'm going to do here is I'm going to label the top equation, equation 1, and the second equation, equation 2. So what we can do in this example is we can do a rearrangement of equation 2. So what we want to do is see if we can get x or y on its own. So we can see in equation 2 we have x plus 2y equals 10. With a little bit of rearrangement we can get x on its own. So x either on the left side on its own or on the right side on its own. So let's take equation 2 and let's say x plus 2y equals 10, and we want to move this 2y over to the right, so we just minus it on both sides. So x equals 10 minus 2y. So we can label this either equation 3, or you can just, refer to it as x. So now what we can do is we can substitute this piece into equation 1, and then we can rearrange using the y terms, and then see if we can get a solution for y, and then what we can do is we can work out the value of x. So I'm just going to plug that into equation 1. So that's 3 and 10 minus 2y minus 2y equals 14. So I'm just going to multiply out the brackets. That's 30 minus 6y minus 2y equals 14. So what we want to do is let's try to move these pieces all onto the right hand side, and then move this 14 over to the left hand side. So we have numbers on the left and then y terms on the right, and then we can do a little bit of division through, see if we can get y on its own. So we have 30 minus 14 because we're bringing that 14 over from the right. So to remove it from both sides, we minus 14 on both sides, and that equals this piece which we've highlighted before, and we're bringing that over to the right. Because there's 2 minuses, we just add them to the right hand side. So that's plus 6y plus 2y. This gives us 16, and that gives us 8y. What we can do is we divide through by 8 on both sides. This gives us y is equal to 2. So that's your y solution. Now we want to just work out the x solution, so we can substitute y into either equation 1 or 2. So if I select 2 because the x is on its own, so x plus 2, and then we've got the value of y being 2 equals 10. X plus 4 equals 10. Rearrange for the 4 to go onto the right. X is equal to 6. So your pair of solutions here for x equals 6 and y equals 2. So the second simultaneous equation that we have here is 2x plus 4y equals 14 and 4x minus 4y equals 14. So label them 1 and 2, just like normal. Cool, so what we can do here is we can use a method called elimination. The reason for this is because you can see in the 2 equations we've got a y term which is the same amount on the first equation and the second equation. So effectively what you can do is if you either add the one equation to the other or minus one equation from the other, you will be able to eliminate that term. So in this one I'm looking at the 4y. We've got a plus 4y on the first equation, a minus 4y on the bottom equation. So we need to just manipulate working through equation 1 and 2 and see if we can eliminate that y. What if we consider that we have the first equation added to the second equation? What will we get? We should be able to eliminate the y term. So if I just label this new equation 3. So this is 1 plus 2, equation 1 plus equation 2. 2x plus 4x is equal to 6x. 4y plus minus 4y is the same as saying 4y minus 4y. 4y minus 4y cancels out, and that gives 0. And then we got 14 plus 4 is 18. So we've got 6x is equal to 18. We can see that both sides are divisible by 6. So what we want to do is just get the x term on its own. So we divide through by 6 here, divide through by 6 there. We have x is equal to 3. So that's your one solution for x. So what we can do now is sub this into equation, say, 2. So let's sub it in. So 4 multiplied by 3, which is the value of x now, minus 4, and then we don't know y yet, so I'm just going to leave it as it is, equal to 4. So that will be 12 minus 4y is equal to 4. We do a rearrangement, bring this over to the left, this over to the right. 12 minus 4 is equal to 4y, and that's 8 equal to 4y. Both sides are divisible by 4, we can see, to remove this 4 piece here. And put that there. That gives us y equal to 2. So the solutions are when x is equal to 2, 3, y is equal to 2. The third example of simultaneous equations, we have a non-linear example. So what we have here is xy equals 24 and then x equals y minus 2. So the approach here is going to be slightly different. So if I start off by labeling equation 1, equation 2. So we've got equation 2 already is in the format of one of the terms equals something else, which includes, the other term that we're looking for. So if we use this second equation, substitute this into the first equation, and then we can do some, standard algebraic manipulations. We could try to see if we can figure out one of the terms. So sub 2 into 1. So that is, so x is now y minus 2, and then all multiplied by y equals 24. I'm just going to expand that out. So that's y squared minus 2y. That's 2 equals 24. If we bring this 24 over to the left, so we're equal to 0, we can work out this quadratic equation. Minus 24 equal to 0. So what we've got to look at is this piece here. So which pairs of numbers do we get that multiply together to give minus 24, but also add to each other or minus, from each other to get to minus 2y. So we can either have minus 6 and positive 4 or minus 4 and positive 6. Both of these pairs will give us minus 24 as the, if you're multiplying them together. However, we need to get minus 2y if we're adding them. So if we add these, we get minus 2. If we add this, we get positive 2. So we know that this is not going to be the solution. It's going to be a minus 6 and positive 4. So then we know now in the pair of brackets, we've got y minus 6, y plus 4 is equal to 0. So the solutions here are, if get this equal to 0 or get this equal to 0. So y minus 6 equals 0. Well, that's y equals 6 because we just move over this 6 to the right. Y plus 4 equals 0. If we move this over to the right, y is equal to minus 4. So we have two solutions in this example. The examples before we've only had one because they seem to be linear equations. So now what we can do is we can use y equals 6, figure out a solution, and then we'll use y equals minus 4 to figure out our second solution. So sub y equals 6 into equation 2, as it's, the easiest one out of the two to sub it into. So then we have x is equal to 6 minus 2. Well, that's equal to 4. So when y is equal to 6, x is equal to 4. That's your first solution. And then y equals minus 4 into 2. X is equal to minus 4 minus 2, which is equal to minus 6. So when x is minus 6, y is minus 4. And that's your pair of solutions for this example. Hope you found this video useful. If you did, drop a like, subscribe if you are new, or if you are already subscribed and you know someone who can benefit from some mathematic tutorial videos, then feel free to share this to them. Thank you for watching, and I'll catch you in the next one.